Welcome to this video on solving equations. To solve equations, you must use inverse operations. Addition and subtraction are inverse operations. Multiplication and division are also inverse operations, as are squaring and finding the square root. When solving one-step equations, remember the step is to apply the inverse operation to both sides of the equation to isolate the variable. The equal sign means that the expressions on both sides are equivalent. Therefore, you must apply operations equally to each side of the equal sign. On your whiteboards, please solve these one-step equations. Y plus 7 equals 10 and 4y equals 12. Determine the inverse operation required for each. Before moving on to two-step equations, let's quickly review collecting like terms. Simplify the expressions shown on screen. Solving two-step equations involves two key steps. First, gather variables to one side and constants to the other. Second, apply the inverse operation to both sides to isolate the variable. Next, let's solve a slightly more complex two-step equation. 7x equals 2x plus 40. Remember the two key steps. Gather like terms, then isolate the variable. On your whiteboards, please solve these two-step equations. 3y plus 7 equals 10 and 4y equals 2y plus 12. Good luck! To end our video, please consider your level of confidence and understanding in solving equations from level 5 to level 7. Before we delve further into complex problem solving, let's establish the order of operations, often remembered with the mnemonic BIDMAS. Brackets are the first step in BIDMAS. This diagram illustrates how the operations inside brackets must be performed first. Try these problems using BIDMAS. Remember the order: brackets, indices, division and multiplication, then addition and subtraction. You can find more practice on the order of operations and expressions and formula within MyMaths to reinforce your understanding. To build confidence and understanding, work through these interactive activities and word problems. Try solving 77 minus 8 times 4. Be aware of common misconceptions in the order of operations. Consider the examples shown and the correct sequence of operations. Here are a few more problems to test your understanding and avoid misconceptions in complex sequences of operations, like 15 minus 12 divided by 4 plus 2. The next step in BIDMAS is indices. Recall what 5 squared means and how to apply this operation. Test your knowledge of indices with these 4 calculation problems. Remember, the index indicates how many times the base number is multiplied by itself. Let's begin with a star challenge on indices. Simplify the expressions 3 cubed times 3 squared and 7 to the power of 4 divided by 7 squared. Welcome to the AP Calculus AB section of this video. We will focus on antiderivatives, differential equations, and slope fields. Let's review a key concept. Consider the equation shown and find the solution. The solution is also provided for your reference. We begin with antiderivatives. Recall, what is an inverse operation? Examples include addition and subtraction, multiplication and division, and exponents and logarithms. Differentiation too has an inverse operation which we call antidifferentiation. Consider a function f of x, whose derivative is f of x. What is f of x? We say f of x is an antiderivative of f of x. We say an antiderivative, not the antiderivative, because of the constant of integration. We can say that f prime of x plus a constant equals f of x. Try to find the antiderivatives for the given equations. Recall the equation from the review. This is called a differential equation and can also be written using Leibniz notation. Solving a differential equation is like solving any other equation. When working with differential equations, we aim to find y as a function of x. Because of the constant of integration, we can only find indefinite solutions. There are 2 basic steps to solve differential equations. First, isolate the differential, and second, invert both sides, which means finding the antiderivative. Since we are finding indefinite solutions, we must indicate the ambiguity of the constant. We normally do this by using a letter, typically C, to represent any constant. Now let's solve the differential equation shown. The solution is provided for you to check your work. Moving on to slope fields, consider the provided link for an introduction to the concept. A slope field shows the general flow of a differential equation solution. They are often used instead of solving the differential equations analytically. To construct a slope field, start with a differential equation. Pick points in the coordinate plane, plug in the x and y values, and the result is the slope of the tangent line at that point. We are now discussing slope fields. When there is no y in the equation, horizontal rows contain parallel segments. Similarly, if there is no x, vertical columns contain parallel segments. We can construct a slope field for the equation dy over dx equals x plus y. This video now moves on to a new section focusing on algebra, specifically for 6th grade, beginning with question number 1. Sarah has 9 envelopes, each containing stamps. If she sells 3 of the envelopes, which expression represents the number of stamps she has left? The options are A, 9s minus 3, B, parentheses 9 plus 3, parentheses s, C, 9s minus 3s, or D, 9s minus s minus 3. The correct answer is C, 9s minus 3s. The initial number of stamps is 9s, and since she sells 3 envelopes, she loses 3 stamps. Question 2. Keisha is painting one rectangular wall that measures 10 feet by 8 feet. The area formula is A equals L times W. What is the area of the wall she will paint? The options are A, 18 square feet, B, 64 square feet, C, 80 square feet, or D, 100 square feet. The answer is C, 80 square feet. This is found by multiplying the length, 10 feet, by the width, 8 feet. Question number 3. If 47 minus n equals 29, what number should replace n to make the sentence true? Your choices are A, 12, B, 18, C, 21, or D, 22. The correct answer is B, 18. Subtracting 18 from 47 yields 29. Question number 4. Write an expression for the number of hummingbirds Louis saw on Saturday. He saw our hummingbirds on Friday. On Saturday, he saw 3 more than twice the number he saw on Friday. The correct expression is 3 plus 2h. Twice the number is 2h, and 3 more than is plus 3. Finally, explain the difference between an expression and an equation. The answer is that an equation has an equal sign. We now transition to a physics quiz. You will determine whether diagrams illustrate acceleration, A, or equilibrium, E. Number your paper from 1 to 5 for your answers. Diagram number 1 shows a box with a 10 Newton force pulling to the left and a 10 Newton force pulling to the right. Is this acceleration or equilibrium? Diagram number 2 shows a 10 Newton force pulling left and a 20 Newton force pulling right. Is this acceleration or equilibrium? Diagram number 3 shows a single 50 Newton force pulling the box to the right. Is this acceleration or equilibrium? Diagram number 4 shows a 50 Newton force pulling left and 2 forces pulling right, one at 30 newtons and one at 10 newtons. Is this acceleration or equilibrium? Diagram number 5 shows a 10 Newton force pulling down and a 40 Newton force pulling right. Is this acceleration or equilibrium? Diagram number 6 shows 2 forces pulling up and down, both at 20 newtons, and 2 forces pulling left and right, both at 10 newtons. Is this acceleration or equilibrium? Now let's go over the answers for the physics quiz. For diagram number 1, the net force is 0 newtons. This means the object is in equilibrium, which I answer E. For diagram number 2, the net force is not equal to 0 newtons. The object will accelerate, making the answer A. For diagram number 3, there is a net force as the object is being pushed by 50 newtons. The net force is not equal to 0 newtons, so the object is accelerating. The answer ISA. For diagram number 4, the forces pulling left and right are both 50 newtons. However, there is a net force on the object, so it will accelerate. The answer is A. For diagram number 5, the forces are not balanced, resulting in a net force. The object will accelerate. The answer ISA. For diagram number 6, all the forces are balanced, so the net force is 0 newtons. This indicates the object is in equilibrium. The answer ISB. We are now moving on to a geometry section, starting with a diagram showing lines and a plane. The green line represents the normal to the plane. This diagram illustrates the angle between a plane and a line that intersects the plane. It also highlights the projection of a line onto a surface. Here we see a prism, specifically showing the angle between the base and the longest diagonal. This diagram further illustrates the angle between the base and the longest diagonal of the figure. Finally, this image shows a pyramid with various line segments and planes represented. This diagram displays a three-dimensional view, likely a geometric shape, emphasizing its various angles and lines. It seems to illustrate spatial relationships. This complex figure again shows a structure composed of multiple lines and points, further exploring angles and intersections in three-dimensional space. This image shows a three-dimensional cube or prism with various lines and planes highlighted to demonstrate concepts of spatial geometry. Now we begin a new section on linear equations, specifically focusing on the world of linear equations. We are looking at writing linear equations in the slope-intercept form, y equals mx plus b. This is crucial for understanding linear relationships. If you are given the slope and the y-intercept, you can easily substitute these values into the y equals mx plus b equation. For example, a slope of 1/2 and y-intercept of -3 results in y equals 1/2 x minus 3. If you are given a graph, you must first find the y-intercept b and then determine the slope m to write the linear equation. As an example, a graph might show b equals -3 and m equals 1/2, leading to y equals 1/2 x minus 3. When given the slope in a point, you can use the point-slope form, y minus y1 equals m times the quantity x minus x1. Substituting the values allows you to derive the final equation. Alternatively, given the slope in a point, you can substitute x, y, and m into y equals mx plus b to find b, the y-intercept. Once b is found, you write the final equation. If you are given 2 points, first find the slope m. Then, use one of the points and the slope to find b using the y equals mx plus b form, or utilize the point-slope form. Finding the slope and then using y equals mx plus b, with the example points of -2, -4, and 2, -2, leads to the final equation y equals 1/2 x minus 3. Welcome to the Polynomials Masterclass video. This video is designed to deepen your understanding of polynomial expressions and operations. Our learning objectives include understanding monomials, binomials, trinomials, degree, and operations such as addition, subtraction, multiplication, factoring, and division of these expressions. First, what is algebra? Variables, constants, expressions, and equations form the very foundation of algebra, which is essential for understanding polynomials. A polynomial is an expression made of variables and coefficients combined through addition, subtraction, and multiplication operations. Examples of polynomials include 3x squared plus 5x minus 7 and x cubed minus 2x plus 1. Expressions like 1 over x or the square root of x are not polynomials. A monomial is the simplest type of polynomial, containing only one term. Examples are 5x, 3x squared, or the constant minus 7. A monomial has several parts. For example, in 8x cubed, 8 is the coefficient, x is the variable, and 3 is the exponent. When multiplying monomials, you multiply the coefficients and add the exponents of like bases. For instance, 3x squared times 4x cubed equals 12x to the fifth power. To divide monomials, you divide the coefficients and subtract the exponents of like bases. So 15x to the fifth divided by 3x squared results in 5x cubed. Polynomials are classified by the number of terms. Monomials have one term, binomials have two, and trinomials have three. Polynomial is the general name for expressions with 4 or more terms. Here are some monomial examples: 7x squared minus 4y and 12. Binomial examples containing two terms include x plus 2 and 3x squared minus 5. Trinomial examples with three terms are x squared plus 4, x plus 4, and 3x squared minus 2x plus 7. The degree of a polynomial is determined by the highest exponent of its terms. For example, 4x cubed plus 2x plus 1 has a degree of 3, while 6x to the fifth minus 8 has a degree of 5. Polynomials are also classified by degree, including constant, linear, quadratic, cubic, quartic, and quintic. Understanding polynomial graphs is key. Linear, quadratic, and cubic functions each have distinct graph shapes that correspond to their degree. To operate with polynomials, you need to identify like terms. These are terms with the same variables and the same exponents, allowing them to be combined. When adding polynomials, simply combine the like terms. For instance, the sum of 3x squared plus 2x plus 1 and 5x squared minus x plus 4 is 8x squared plus x plus 5. You can practice addition by combining like terms in various polynomial problems. For subtracting polynomials, remember to distribute the negative sign to all terms in the subtracted polynomial before combining like terms. For example, subtracting x squared minus 2x from 4x squared plus 3x yields 3x squared plus 5x after distributing the negative sign. Practice subtraction by changing the signs of the second polynomial and then combining the terms. When multiplying a monomial by a polynomial, use the distributive property. Multiply the monomial by each term inside the parenthesis. The FOIL method is used for multiplying two binomials. It stands for multiplying the first, outer, inner, and last terms of the binomials. Using FOIL, the product of x plus 4 and x minus 5 is x squared minus x minus 20. Factoring with the greatest common factor, or GCF, involves pulling out the largest term common to all terms in the polynomial. For example, 6x squared plus 12x factors to 6x times x plus 2. Factoring trinomials involves finding two binomials that multiply to the original trinomial. For instance, x squared plus 5x plus 6 factors into x plus 2 times x plus 3. The difference of squares is a special factoring case, where a squared minus b squared equals a plus b times a minus b. Thus, x squared minus 16 factors to x plus 4 times x minus 4. Now take some time to solve several factoring problems to practice these methods. Polynomial long division is similar to arithmetic division, allowing you to divide a polynomial step by step to find the quotient and remainder. As an example, dividing x squared plus 5x plus 6 by x plus 2 results in a quotient of x plus 3. Synthetic division is a shortcut method for polynomial division, but it can only be used when dividing by a linear factor. Polynomials have real-life applications across various fields, including engineering, economics, physics, computer graphics, and construction. Let's review the key concepts and operations we covered in this video, including classification, addition, subtraction, multiplication, factoring, and division. Test your understanding of polynomial concepts by answering some multiple-choice quiz questions. Review the solutions to the quiz questions to check your answers and reinforce your learning. Thank you for watching this video. Continue to practice your algebra skills, especially working with polynomials.